welcome back. Up next, we're going to be talking about a bunch of different things, including reducing time to market, because ain't nobody got time for that. And also semiconductors in a semiconductor crisis. We've been messing around with this, but who better to talk about these topics and more than Associate Vice President at Arrow Electronics. He climbed Mont Blanc once, and he'll be climbing up on our stage to present to you. Please give it up for Davey!
Thank you, Justin. Thank you very much. Good afternoon, everyone, and welcome. So, as Justin introduced me, my name's Davey. I'm our Associate Vice President of our Design Services business here for Europe. Just a very brief background onto this. So, I work for Arrow Electronics. In terms of scale, we're a $35, $36 billion distribution company. And back in 2018, we acquired a company called Unification as a design services business. We currently have around 3,500 engineers based both in India, North America, and are expanding into Europe. And today, what I wanted to give you some insight into was really the growth opportunity that's coming, the technology adoption. I'm going to touch slightly on semiconductor and the view of semiconductors in technology. And then I'm going to finish just about innovation and the importance of innovation in this space, and also just touch on talent as well, and the challenges around talent. And all of this encompasses basically digital innovation or digital transformation for our customers and how we move forwards with that. So, right now in this room, I would say it's probably the most exciting time to be in technology today. And I'll explain why the future technology adoption is going to really start to accelerate compared to where we've even been in the last 30 years. So the predictions are, and if we look at roughly where we are as a semiconductor market, which translates then into technology usage, we're about just under $600 billion today. So I think the number at the moment is something like 589 or something like that. To put that in perspective, and the future prediction, by the way, is that we're going to be a $1 trillion business of semiconductor sales in the next decade. And to put that in perspective, it's taken us about 30 years to get to where we are today, from the introduction of semiconductors to our business today and how we see it moving forwards. And then in the next less than 10 years, we're going to almost double that business. And the expectation on that is effectively the electrification of everything that's coming. And I'll touch on the growth areas that we see in this space as well. Not only that, to derive that amount of semiconductor consumption, of course, you're going to have a very significant amount of engineering resource to support that effort moving forwards. And that's where we see effectively 3 trillion of R&D costs globally being utilized to create this level of innovation that's expected. And we're likely to see a continued expansion of outsourced engineering, and primarily to not necessarily take engineering resource away from customers moving forwards, but to actually augment some of the technology requirements needed to be able to innovate so successfully in this space. If we look at what is actually driving this technology adoption, first of all, if we look at hyperconnectivity, and I bring that up because of clearly this event here, the amount of connectivity that's taking place. And we've had this space moving forwards. We've had connectivity growth, certainly through the cellular market, for the last 10 years. But we're now starting to see very significant connectivity expansion onto our industrial customer base, onto the connected cars, et cetera, moving forwards. And that hyperconnectivity then, of course, expands the amount of cloud and data service usage that you're expecting to see too. From cloud-native applications, I'll just give you some sense as to why that's important for technology adoption, but also the sense of semiconductor and technology usage, is that we're now reducing the silos. We now have an ability to start sharing data, or even selling insights and selling data through business-to-business connections within the cloud service infrastructure itself. If we look at edge and edge deployment, and I know behind me there's lots of conversations talking about the actual compute, on how much compute is taking place on the edge versus how much is taking place in the cloud. And I think with LoRa in particular, this is a very important space where you've got relatively low payloads, required data transfer through LoRa. Therefore, you do need a level of edge compute to be able to achieve the results you're looking for. And as we continue to see basically semiconductor gate technology and the amount of transistors expand through Moore's law, we're going to see a further computational power that's going to happen at the edge taking place there. AI, I don't think there is really a need for me to touch on the expansion of AI. Every customer I speak to is looking for a level of AI optimization or AI development that they're working for. And then if I look at autonomous machines, again, we think naturally about cars and automobiles is what's going to drive the autonomous machine space. But I think that's not just that area. We're also seeing it through customers looking at farming, aerospace and defense. We see also a lot of airplane infrastructure as well, looking for some level of autonomy to move their business forwards. And then finally, if I just touch on the electrification of everything, and here what I'm encompassing is where we have motor and motor drive technology driving something, and again, we naturally think of cars. But again, what we're seeing is that anything that involves some form of internal combustion engine will be moving towards power-driven electronics moving forwards. And I think it's that whole space that's absolutely driving this enormous amount of growth expectation over the next 8 to 10 years. So I've touched on the markets that are going to be driving it, but I now wanted to just talk about the technology that was driving this adoption moving forwards too. So if we look back over the last 10 to 15 years, the bulk of technology adoption has really been around the consumer space, wireless, as in the cellular architecture, and also we look at wired communication as well. So wired communication being servers and the whole infrastructure around server technology and how that's driving that space. Now what we start to see is an incredible growth market in some of the core, I would say, European areas that we're starting to see here. So if we look at industrial, this is clearly, Europe is the heartland for industrial electronics and electrification driving forwards. If we look at automotive, as I mentioned before, and that's not to be expected, of course, we would expect a large amount of automotive, but also wireless communications. And within that wireless communication space is, of course, 5G and the adoption of 5G, but there's also a whole host of other wireless protocols that is driving that activity too. And then I think if we just come back quickly, just touching on the industrial electronics space and what we're seeing to drive this area, and I think it nicely comes into the theme of this event around digital transformation, is many customers now in that industrial space are looking for new business models to transform themselves moving forwards. So in the past, they often had a business model of developing a product. That product would then be sold, and obviously their margins would be based on the selling price of that product moving forwards. But through digital transformation, connectivity, and the level of insights that they're providing to their customers, they're now looking at much more towards a rental or rateable model moving forwards, and looking at obviously that repeat business that is on a monthly cycle or on a quarterly cycle, rather than just a one-off single transaction. But that is quite hard, by the way. If you start talking, and maybe many of you are, to some of these core industrial customers that have been making physical products for 20, 30, 40 years, to move to this new digital transformational business model is quite hard for them to actually do themselves inside their own business. So the next bit is, and I wanted to give you some insights really just on our background from Arrow about foundry capacity, the semiconductor crisis, and really what we see moving forwards that's going to help relieve some of this, but also quite important for anybody either in hardware design activity today or is speccing something from a hardware design activity to consider when you move forwards exactly the design cycle behind that. And let me just give you some insight into what I'm trying to show here. So the way that we typically have foundry capacity today, we have it in two main areas. We have what we call leading edge, which is typically sort of 200 nanometer or 12-inch wafers. And the bulk of the microcontrollers, the bulk of the products that you are probably using today in the industrial space currently is sitting on that 200 millimeter wafer. Then the next generation wafers are 300 millimeter wafers, which is 15-inch wafers, so these are the much larger ones. And they have many of the very bleeding edge technologies on there. So if you think about 5G adoption, Apple's iPhone and the components in there, memory technology, for example, nearly all of that will be sitting on this next generation wafers. And as you can see on the graph I'm showing down here, the investment in 300 millimeter is very significant. And that's across the world, not just in China. If we look at what I would consider still leading edge, but is more mainstream today, the 200 millimeter, the investment in foundry capacity is mainly coming out of China today. And the reason why I bring that up, we may hear over the next 12 to 18 months that there is a softening in the market because of the geopolitical, because of inflationary pressures, et cetera, et cetera. But I think it's unlikely, as you can see down there, related to automotive, which is going to be similar to industrial and similar to other areas, we will still expect very significant growth in those market areas moving forwards. And those areas typically drive consumption of 200 millimeter wafer product. So the sort of microcontrollers and the other sensor activity that would come from that space. So really my advice here, if you're manufacturing hardware, is to really contemplate, or at least make a conscious decision about the type of technology that you're using in your product as you move forwards. And the reason for that is, if we just look at some of the costs that have been associated to that. So on the far side, what we see is we actually have some of the legacy nodes, see some of the older technology that's still very much in use today, but very significant price rises from that have happened over the last 3 years. But whereas if you look at the much more modern technology, you can see that the pricing is much more stable, and you can see that basically it's, the capacity is of those products is also going to be greatly enhanced. So my advice here really would be, when you are looking at a redesign activity, if you are looking at your partner that you're working with, do consider about what technology they're using, and also don't necessarily take product that is in a design today and then try and reuse it in the next generation products that you're manufacturing. I think that reuse activity certainly can cause some challenges. Now I'm just going to touch a little bit on this area of innovation and engineering talent. So if we look at our engineering teams over the last, certainly over the last 2 years, post-COVID activity where we saw this enormous growth taking place, and we saw a very significant shortage in the semiconductor space. Most of our customers' engineers have actually been working on redesign activity in this space. So that is basically sustaining the existing products they have today, not really innovating for new products, and that has created this lack of innovation in a number of customers because they just haven't had the ability to go and create new products with new features. So you end up with two things happening here, actually. One is, so this re-engineering and sustaining activity is not very exciting for engineering teams to be working on, and therefore you can end up in a situation where you have talent attrition, effectively, because they're not working on exciting new innovative products moving forwards. The second thing is, from a business perspective, because we've had this innovation vacuum because of the semiconductor crisis that's taken place, we are highly likely to now see an acceleration of innovation by our larger customers and the customers that are already in business today to try and catch back up on next generation products, to invest more in their next generation technology as they move forwards. And the reason why I then bring up talent is because, of course, they're going to want to attract talent and retain talent into that space to be able to go through this innovation cycle that is going to be critical for them, for their next generation product portfolio. And then finally, if I just talk about the electrification of everything here, and what we start to find that's going to drive also significant consumption of talent in this space is really twofold. One is, as I mentioned beforehand, just the enormous amount of redesign and design activity that's going to take place with automotive products, and not just automotive, but the whole infrastructure that surrounds that. This whole digital transformation in core industrial customers, again, is going to drive talent consumption within the market space. But finally, if we look at where we're going with green energy and the pressures that are coming on us now because of fossil fuels and the price of fossil fuels, we're now seeing governments start to plow huge amounts of money into these green innovations, which again consumes a lot of engineering talent and a lot of innovation taking place. So I think we will see, certainly for the next 2 years, a talent challenge because of these activities. Now, if you look at what we do, so we're starting to see our business expand rapidly because we're filling in parts of the gaps that are in this vacuum for talent today within the E-Infochips business. And as I mentioned before, so we have 3,500 engineers across Europe, India, and North America, and we're continuing to attract talent into that space to basically fill areas where our customers today find that they're having gaps. And I'll quickly run through the 4 areas where I think we can add some value here. So first of all, we have a product engineering team, and this is exactly what you expect almost an outsourced engineering team to work on. So we can take a design, a product that you may be wanting to create or implement today, and we can either help with your development, or we can take it and do a complete end-to-end product from design, manufacture of hardware, software, packaging, PCB, but also behind us, of course, we're attached to a $35 billion distribution company, and we have the ability then to ship your product globally into a market space. Secondly, around digital engineering, and actually the digital engineering team is probably our fastest growing segment today. This is a team that helps customers go through that digital transformation. So we can basically build cloud infrastructure, we can build insights and data. We also maintain and look after the firmware adoption of that and manage also the app development moving forwards. Quality engineering in this space is probably one of the most critical areas from a safety perspective. This being that we can look at test and test automation of your device and product when it's in the field. And really what we're looking for here is, with new security regulations coming out from Europe, you need to be extremely careful about how you look at certifying your product and bringing your product to market. So we can help basically create a test environment that allows you to maintain your product for the future moving forwards. And then finally, just really around our silicon engineering space. Silicon engineering is an area that continues to be supported by a lot of our semiconductor partners today. But we have seen some OEMs basically want to take ownership of their own IP and their destiny within the supply chain. And those customers are starting to look at manufacturing their own silicon products for their own consumption rather than mass market. I mean, I put up some of the names here, but really this is just showcasing some of the larger customers that we have helped through that digital transformation journey. A lot of them are sort of core industrial customers where we've added effectively hardware design and wireless capabilities, but then also looked at managing their cloud infrastructure and app development too. So let me just summarize where I think the 3 areas that, in this space today, if I was going to give you some advice where I think you would focus. First of all, don't underestimate the future of component supply chain or having a solid supply chain management in your own business today and your business moving forwards. I think we may see a small window where there is some relief on semiconductor supply chain, but I think very quickly that's then going to be consumed again, when we start to see some of the explosions of the electrification of everything. I think customers and companies more and more are looking to innovate, and I would say, and really consider how you manage your talent through that innovation pool. And I would say, certainly the next 12, 18, 24 months, there's going to be a huge amount of talent usage within companies to create that innovation activity. And then finally, as I mentioned before, just around test and test automation, please don't look at launching a product into the market today that has an inability to test your firmware delivery to that moving forwards. And that, clearly we can help you with that if needed, but just take that as some advice that I think launching product into the market where you have no way of testing firmware or no way of managing security is going to be a highly risky activity if you were to venture into that. So with that, I'd like to say thank you. Really appreciate your time, and hand you back to Justin.
Thank you so much for that. Let me grab the clicker from you. Thank you. So up next, we're going to be talking about the unification of IoT, and a fun fact about our next speaker. He's an Aussie stranded in Stockholm, all thanks to IoT. So